Alrighty, this is 1-1, measuring segments and angles, day 2. So recall from day 1 that an angle is formed by two rays with the same endpoint. Okay, each ray is a side of the angle and the common endpoint is the vertex of the angle. You cannot name an angle just by its vertex if the point is the vertex of more than one angle. In this case, you must use all 3 points to name the angle, where the middle point is always the vertex. So for example, if we're looking at this angle here, and if I were to refer to this as angle B, it'd be a little bit confusing which angle I'm talking about, right? I could be referring to this entire thing, or I could be referring to one of these parts of that entire angle. So if I'd like to name this whole angle here, I would need to call this either angle CBA or angle ABC. Remember that that middle letter needs to be the vertex. There are a couple different types of angles and we can classify them a couple different ways. Let's first talk about angles classified by measure. So if we have an acute angle, those are angles whose measures are greater than 0 and less than 90. A right angle measures exactly 90 degrees. An obtuse angle is greater than 90 and less than 180. And a straight angle is exactly 180 degrees and is formed by two opposite rays. We can also classify angles based off of angle pairs. So adjacent angles here are two angles with a common vertex, so in this case right here, and a common side. So we have two angles here which share this common vertex and that common side. For the sake of it, we'll label these A and B. Those are adjacent angles. A linear pair is a pair of adjacent angles, right? These two angles share a vertex and a side. However, the non-common sides here are opposite rays. That forms a linear pair. We'll name those A and B. Complementary angles are two angles whose measures have a sum of 90 degrees or who add to 90 degrees. So for example, 53 degrees plus 37 degrees gets me 90. They can be separate angles as shown in the picture, or they can actually be adjacent angles as well. So I could draw something like this, where this is 37 degrees and this is 53 degrees, and together they sum to 90. Supplementary angles are two angles whose measures have a sum of 180 degrees. So add to 180 degrees, 53 plus 127 gets me 180. Just like complementary angles, they can be separate or they can be drawn as a linear pair. So I have 127 degrees here and 53 degrees here. Alrighty, the last angle pair we're going to discuss then are vertical angles, which are two non-adjacent angles formed by two intersecting lines. So non-adjacent, adjacent means next to. So two not next to angles formed by two intersecting lines. In this case, we could be talking about these two angles, A and B. Something special to note about vertical angles is that they are always equal to each other. Okay, always equal. We'll do some practice identifying all of those types of angles in class. But moving on for now, we'll talk about the angle addition postulate, which is pretty similar to our segment addition postulate. It says that if point D is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. Let's practice using that. It says that given that the measure of angle JML is 80, I'm going to label this as we go. This angle is 80 degrees. And the measure of angle KML is 33 degrees. What is the measure of angle JMK? So we know based on the segment addition, the angle addition postulate, that the measure of angle JML is equal to the measure of angle KML plus the measure of angle JMK. Okay, I know that JML is 80 degrees and that KML is 33 degrees, so I'm going to replace those in my equation. And then I'm going to use my algebra skills to solve for the measure of angle JMK. So I'm going to subtract 33 from both sides. And I'm going to find out that 47 degrees is equal to the measure of angle JMK. I'm going to try to keep this video nice and short, so we're actually going to leave questions 2 and 3 for in-class practice. All right, some more vocabulary. An angle bisector is a ray that divides an angle into 2 congruent angles. And recall from class the other day that congruent means equal. All right. So it says that ray PR bisects QPS. The measure of angle QPR is 6x plus 3, and the measure of angle RPS is 8x minus 7. Find the measure of angle QPS. All right, so let's label this diagram. I think that's going to be helpful. It said QPR right here is 6x plus 3, and that RPS is 8x minus 7. Because it says that ray PR bisects this entire angle here, we know that those two are equal to each other based off of our definition above. So what I'm going to do is set those two values equal to each other. I've got 6x plus 3 equals 8x minus 7. Let's all subtract 6x from both sides. Add 7 to both sides. And divide by 2, and I should find that x is equal to 5. Bringing it back to our angle addition postulate, I know that these two parts are equal to my whole, right? So I know that the measure of angle QPS is equal to the measure of angle QPR plus the measure of angle RPS. Right. And based on the information above, right, I know that the measure of angle QPR is 6x plus 3, and I know that the measure of angle RPS is 8x minus 7. All right, because I was able to solve for x up here, I'm going to plug in 5 wherever I see an x. So the measure of angle QPS then will be equal to 6 times 5 plus 3 plus 8 times 5 minus 7. Okay, that's going to get me 30 plus 3 plus 40 minus 7, which means that the measure of angle QPS is going to be 66 degrees.